So before we get into the content of the presentation, I'd just like to acknowledge my co-investigators, researchers and collaborators who have worked on this project. And especially I would like to credit the funders, the Stroke Association and the Rose Trees Trust. I think they've taken a bold step as medical charities in funding methodological research of this nature. So thanks to them. So a brief outline of where we're going to go today. I'll open with some background and give an example from the context of stroke trials to motivate the work. And then there'll be three main parts to the presentation. First of all, a survey of Cochrane systematic review authors, and then secondly, reporting on systematic review of the methodologies for recovering missing standard deviation and missing mean values where they're not available in trial reports. And then thirdly, we'll look at a real-world application of some of the methods that those reviews identified. And we'll close with some conclusions and discussion about possible further work. So the motivating example is a stroke trial where hospital length of stay is a frequently measured outcome. And most patients with acute stroke have a length of stay of somewhere around 10, 11 days, but occasional patients will have very long hospital length of stay of 20-something or 30-something days. And so if we're summarizing those lengths of stay, then the mean, which in this case is an average of 12 days, doesn't feel like a completely appropriate summary of the experience of the typical acute stroke patient. Whereas if we were to summarize the values using the median, say, which in this case is 9 days, that seems to be an appropriate descriptor of the experiences of most acute stroke patients. So what are the consequences of this? Well, they are twofold. And the first issue is that because of those patterns in some continuous outcomes, the mean and standard deviation may not be available in the trial report, and instead values like the median and interquartile range might be reported instead. And as a result of that, potentially the standard meta-analysis can't be used, and those trials might need to be left out of the meta-analysis. And the second issue is that in some instances, doing a standard meta-analysis wouldn't be appropriate at all, and so alternative methods would be required in those cases. So this presentation today will focus on the ways of tackling issue number one there, where the mean or standard deviation are unreported. So at this point, we'll switch to the first polling question to hear about your experiences. And so this question is about whether you have encountered missing standard deviation or mean values when you've been performing a systematic review or meta-analysis of a continuous outcome. Thanks for your responses there. So a vast majority of you have experienced this problem in performing a review, and we'll see how that compares to the results of the survey that I'm about to discuss. So just to recap on the aims again, we're going to have discuss this survey that we did of Cochrane Review authors to establish the extent of this issue, and then go on to discuss the findings of systematic reviews of the methods in the literature to recover the mean and the standard deviation where those are missing from the trial report. And then finally do a real-world test of some of the methods using individual patient data from a Cochrane review of stroke rehabilitation interventions. So to the survey of Cochrane reviewers, the design of this, we focused on stroke rehabilitation. Partly we purposefully selected this as an area where we knew that continuous outcomes were prominent in studies, and also it was a topic that was of great relevance to the funders of the work. So we sent out the survey to the lead and second authors of each of the reviews, and if the contact author was someone other than those two authors, we also sent the survey to them as well. So there was a covering email sent out with the invitation, and we conducted the survey in Google Forms, except for recipients who were in China, where it wasn't possible for them to receive the survey in that format at the time of the survey in that location. So those recipients received the survey in Word or PDF form instead. And an important point is that the questionnaire was linked to a specific review experience. So if individuals had authored more than one review among the list of reviews, that they would make separate responses for their experiences in each of those reviews. So in terms of the findings, at the time of the survey, there were 177 stroke reviews listed in Cochrane, and of those, 70 were of rehabilitation interventions. The survey went out to 141 authors, and we received 63 responses, which covered just over 3/4 of the 70 reviews. Almost all of the reviewers had aimed to extract continuous outcomes as part of the review, and just over 2/3 of those had encountered issues with unreported mean or standard deviation values. Despite that, the vast majority of those still undertook a meta-analysis as part of their review. So interesting that figure is somewhat lower than the experiences of the perhaps selected group of people who have joined the webinar today. So how did the authors handle these missing mean and standard deviations in the reviews when they attempted a meta-analysis? So the vast majority went back to the trial report authors, a very sensible first step, but in many of the cases where they did so, they weren't able to retrieve the information that they'd requested from the trial report authors. Others had used other information in the trial report, whether that was data from graphs or working backwards from other information to try and estimate the unreported mean or standard deviation value. About a quarter substituted a similar value for the missing information, either the mean or the median rather in place of the mean, or range in place of as a measure of the indicator of the standard deviation. And about 15% either used imputation techniques or actually changed the method of analysing the data. So, for instance, dichotomized the continuous outcome. And about a fifth of respondents used some other sort of approach. So, as you can see, a diverse range of approaches used, but the significant bottom line is that about 3/4 had to leave at least one trial out of their meta-analysis because of the missing information. So at this point, I'd like to see how that matches up with your own experiences, and we'll move to polling question 2, which is about the methods which you've tried to tackle the issue of missing mean or standard deviation values. And here, I request that you take all of the options that you've used rather than just selecting one from the list. Thank you for your responses to the poll there. Interesting to see the patterns in the findings. Broadly similar to what we saw in our survey of the stroke rehabilitation review authors. Perhaps a few fewer having to omit trials from the meta-analysis, and perhaps a bit more active use of imputation approaches and use of other information in the trial report. So thanks for sharing your experiences there. So now let's move on to the second part of the webinar and talk about the systematic reviews of methods. And I'll just give a brief description of the methods for first of all, the systematic review for methods for replacing standard deviation where that was missing from a trial report. Our aim here was to update a previous review published in 2006 by Viva and colleagues. So we were interested in methods for determining the variance, standard deviation or standard error, and restricted our attention to parallel group or crossover trials. One reviewer screened the title and abstract and full text to identify eligible articles, and then an independent reviewer assessed full text to confirm eligibility. And we assessed a range of electronic data sources from Medline, Embase, and so on. We looked at full text listings, and I think importantly for a review of this nature, we focused on grey literature, in particular Cochrane colloquium abstract books, the mailing list archive from the Cochrane Statistics Methods group, and also direct emailing to topic experts on the Cochrane Statistics Methods group. And I think that was a very important element in this type of review where the methods are perhaps not so straightforward to find by standard literature searching techniques. And just to flag up at this point that all the detailed findings of this review of standard deviation methods and also the other review of methods for the mean are published in this paper in BMC Medical Research Methodology. That gives rather more detail on technical aspects of the methods. So today's webinar is going to focus more on the general pattern in the findings. The next slide summarizes one of the example search strategies from, in this case, Embase. is not intended to be read, but really just to illustrate the complexity of search terms that one has to use when trying to identify methodology that's associated with terms such as standard deviation and mean, which occur very commonly in the literature. So this complexity of search is needed to get to a level where at least you can guarantee that you will find the key papers that you already know exist in the literature, and then use that as a basis to move forward. So here's the flow diagram of the review findings, and out of about 900 articles that were identified, 238 were assessed for full text, and of those, 161 were found to be relevant, although only 15 of those actually presented novel methods for ways of replacing missing standard deviation values. So let's look at the list of the methods in a little more detail. Here's the summary slide, and quite a number of papers addressed the issue using Bayesian meta-analysis approaches. Other approaches were based on formulae, based on summary statistics, or weighted average approach, or meta-regression approach, and there was one paper used approximate Bayesian computation methods. So we selected 5 methods for further study, and this was done on the basis of the potential ease of use of methods by participants. This was a perspective that we took into the whole project, that we were seeking methods that could be applied practically and didn't necessarily require specialist knowledge to implement them. So that was the rationale for focusing on these methods. But I'll be interested at the end of the webinar to discuss that perspective. So in terms of these 5 methods that we selected, the one by Hoso and colleagues was a formula-based method using the minimum, maximum, and median values. The paper by Walter and Yao presented a lookup table, which was a variation on the range method, so using just the sample size and the minimum and maximum values. Ma and colleagues presented a weighted average method using the variances that were observed in other studies in the systematic review. And then both Wan and colleagues and Bland also provided formula-based methods using other summary statistics presented in the trial report. It's worth pointing out at this stage that the method by Wan and colleagues was actually very similar to the approach that was recommended in the Cochrane handbook at the time of this work. So in later parts of the presentation, we actually look at the Cochrane handbook method as a comparator as well. So moving on from the systematic review for standard deviation to the one for missing mean values, the methods were broadly similar. I won't go into them in detail, but we did slim down the electronic searching scope in this review based on experiences in the standard deviation systematic review, because of the overlap of identified articles across sources. And again, there was valuable input from feedback from members of the Cochrane Statistics Methods group to make sure that we were through our literature searching strategy, not missing out on any key methods that were currently being presented. Here's the flow diagram for the review of methods to identify missing mean values. So after identifying 1,100 or so articles, many of them actually through cited reference searching of the important paper by Hoso and colleagues. 45 were then selected for full text review, and from those, 4 presenting new methods were identified. So this slide summarizes the methods we identified, plus those published in that seminal paper by Hoso and colleagues, which we also included as part of our study. And again, for the same rationale that I described earlier, we selected 3 of them for further study based on potential ease of use, in addition to the others identified, which use Bayesian meta-analysis or approximate Bayesian computation approaches. So let's now move on to the case study, and this was a Cochrane review of early supported discharge interventions after stroke. We managed to acquire individual patient data from that published review, and the review contained the data set which we were able to access from the review contained 8 trials covering a total of 1,055 patients, so reasonably representative of the sort of number of trials and size of trials that one would expect, certainly in the stroke rehabilitation trial context. One of the key secondary outcomes in this review was hospital length of stay, and the overall result for that hospital length of stay outcome, perhaps not surprisingly given that the intervention was early supported discharge, was a significant benefit of a mean difference of minus 9.4 days with a confidence interval from 2 to 16 days. So we used data from this review to assess how successful methods could be in recovering unreported standard deviation or mean values under scenarios where these were missing from 1 or more trials. And specifically, we looked at whether there was bias compared to the true result that we knew from the full systematic review meta-analysis, and how accurately the precision in that result was reflected when using these methods for recovering mean or standard deviation. And as a comparator, we also looked at how they perform compared to missing out a trial with an absent standard deviation or mean from the systematic review. So I'm just going to walk through a summary of the findings now, and so just to get orientated in what we're seeing here. So first of all, we're taking the methods for missing standard deviation, and in this first graph we're looking at the question of bias compared to the true result from the example systematic review. So the horizontal line at 0 corresponds to no bias, so that is the most desirable point on the graph. Different colours correspond in blue to the weighted average method of Ma and colleagues. Orange deals with the adapted range method from Walter and Yao. The green bars correspond to the Cochrane Handbook method based on the interquartile range. And the purple bars correspond to omitting the study from the meta-analysis. And then horizontally along the graph, each block of bars corresponds to what would happen if we imagined that the standard deviation was missing for that trial, labelled by the location of the trial. So for instance, the first block was a trial performed in Adelaide, Australia. And so we imagined that the standard deviation wasn't available for that trial, and then analysed the data, recovering the standard deviation using each of the four methods that I've described. So overall, what we see from this graph is that in several cases, omitting the trial from the meta-analysis does lead to substantial bias in the conclusion. And the method by Walter and Yao performed the best. So here, the less of a particular colour there is on the graph, the better in terms of minimising the bias. And the Cochrane Handbook methods and Ma methods also performed well with regard to bias. So still staying with missing standard deviation values, the next graph looks at the precision of the conclusions. So the structure of the graph is the same in terms of one block of bars for each, taking each trial in turn and considering the standard deviation to be unavailable for that trial. But here, the precision is measured as the ratio of confidence interval width. So a value of 1 is the most desirable on this graph. In terms of the results, occasionally omitting a trial or using the Ma weighted average method leads to rather incorrect precision in the result of the meta-analysis, whereas the Walter and Cochrane Handbook methods both performed well in that regard. So that was the findings for standard deviation. What about the results for missing mean values? So here, the methods that were considered were the methods that were based on formulae using alternative summary statistics. In blue, we have the approach by Hoso and colleagues based on the median, minimum, and maximum. In orange, we have the method by Bland, which deals with those summary statistics, plus the lower and upper quartile. In green, we have the method by Wan and colleagues, which uses just the median, lower and upper quartile. And again, in purple is the comparator of omitting the study from the meta-analysis. So this graph, again, 0 is the reference line because it's bias that we're looking at. And the method of Wan and colleagues in the green bars performs best. Next best is the method by Bland, and finally the method by Hoso and colleagues, and omitting the trial from the meta-analysis in several cases leads to important levels of bias. In terms of precision and the missing mean, so here we have again, substantial imprecision in some cases when omitting the trial from the meta-analysis. And that also happened a number of times using the method by Hozo and colleagues. Again, the method by Wan and colleagues proved best, with the method by Bland also performing well. So drawing all that together then, it's clear that unreported mean and standard deviation can lead to trials being omitted from meta-analysis. And there's been a useful number of methods published recently to address this. And in our reviews, we identified 15 approaches for unreported standard deviations and 5 for unreported means. In the case of standard deviation, the adapted range method of Walter and Yao performed best, but it does need the minimum and maximum value to be reported in the trial report. The Cochrane Handbook method also performed well if the upper and lower quartiles were available. In the case of the mean, the method by Wan and colleagues got most reliably closest to the true value, and because it uses values that are often reported, it's probably most likely to be practically useful. So at that point, I'd like to move to the third and final polling question, was just really to find out your views on the perspective that we took to this research. So when selecting a method, is it best to go for methods that can be broadly applied, are straightforward for non-specialists to use, or is strong technical performance of method in terms of unbiasedness and good coverage the focus that we should take when selecting a method? So interested to hear your opinions on this. So thank you for that. Fairly clear balance of opinion there, about 3/4 in favour of focusing on the technical performance of methods versus the applicability of methods in practice by non-specialists. So that's a clear viewpoint there. So just drawing together some final thoughts, as I mentioned at the beginning of the presentation, sometimes meta-analysis based on the mean and the standard deviation might not be appropriate, and in that case, other methods such as ratio of mean or ratio of geometric means that do not depend on these values might be applied. And one extension to this work, which we are exploring, is to follow the similar methods to evaluate the performance of the more straightforward of these approaches in comparison to the very technical methods which are also available. I think a take-home message for me is certainly that one shouldn't be recommending a single method in this scenario, because if you're relying on other statistics being reported in the trial report, these might not be consistently available for all of the trial reports. So a mixture of methods might be required, and certainly looking at the original trial reports of the source trials for that early supported discharge review, that was certainly the case, that in terms of what was and wasn't reported in the original trial reports in terms of alternative summary statistics. And I think as a closing statement, obviously the promoting the high quality reporting of trials to address this issue is paramount. But I think some strategy along the lines we've been talking about today will always be needed to make use of historical studies and to draw in the full body of evidence on a particular topic.